Okay, so interaction of two hydrogen atoms. So hydrogen this is H atom. Hydrogen is the simplest atom, so it's easy to understand it. So it's another atom. So when they are far apart, sufficiently far apart, there will be no interaction. There will be no interaction. Now, when they start coming closer to each other, so let's say they are started coming closer to each other, that's where interaction happens. Okay? So when they come close together, they started interacting, and that's where the bond between, let's say this is plus nucleus for one hydrogen, and you see that more density between those hydrogens atoms. This is electron density. That's where they achieve lowest overall energy of system, of this whole system. That's where you can say H2 bond happens. H2. They started with H bond, H atom, and that's where H2 molecules. Let's say H2 molecules. And whenever in a chemical bond, most of the time, outermost electron, valence electron, they try to interact. Okay, so when you see graphically this interaction, I'm going to draw to next slide. Internuclear distance. It's in nanometer, it's very small. And potential energy, kilojoules per mole. So, let's say this is a zero line when they start. So let's start with here. Whenever they are zero, when you see they are far apart, okay, when they start coming closer to each other, and here they start joining, and you can see that H2 molecules. So initially when they are far apart, their potential energy is about zero. Then when they come close to each other, lowest energy achieved, and that's where you can see the potential intermolecular distance between those hydrogen atoms decrease. You can see when you extrapolate, and that's where you get bonding happen between H and H bond. So when you write H and H bond length, so now let's talk about two kinds of chemical bonds, ionic bonds and covalent bonds. So we'll talk about two types of general bonding, okay? So let's go to next slide. Ionic bonding. Covalent bonding. Ionic bonding usually occurs between, you know, that metal and non-metal. Covalent bonding between non-metal and non-metal. So I'm going to give you an example for ionic bonding. Let's say this is Na. Na has one outermost electron since it is in group 1. Chlorine has 7 outermost electrons. I'm trying to draw that. 7 valence electrons. Now, Na is metal and Cl is non-metal. Metal has a tendency to lose electrons. Non-metal has a tendency to gain electrons. So what happened when Na and Cl come close together? This metal is going to donate its 1 electron to chlorine. Okay. And by doing that, chlorine is gaining 1 more electron. By doing that, chlorine achieves octet. Octet means 8 electrons in its outer shell. Okay, so that means chlorine is it is happy, means 8 noble gas configuration chlorine is achieved. And here sodium, when they lose these electrons, it achieves noble gas configuration, stable configuration. Okay, so in that case, when Na lose electrons, it becomes Na plus 1, and the chlorine receive 1 electrons, it becomes Cl minus 1. And those ions, when they attract, positive and negative ions, when they attract, that's where ionic bonding happens. Alright, because positive and negative, they attract. So this bonding happens when electrons transfer. Electrons transfer. Electron transfer, and you can see due to attraction between positive and negative charges. So that's ionic bonding. Okay. Now we are going to talk about covalent bonding. Let's talk about between non-metal and non-metal. So we'll say chlorine. We'll take an example of chlorine. It has 7 electrons. I'm going to represent with a dot. 7 electrons. And other chlorine has 7 electrons. Now none of them they can donate. They both can gain electrons, but they don't want to donate. So, but they want to get stable configuration. They want to achieve stable configuration. So in that case, what they do, they share the electrons to become 8 on both sides. So they said, okay, we are sharing those 2 electrons. When they do that, this chlorine has 8, 1, 2, 3, 4, 5, 6, 7, 8. And this chlorine has 8 electrons, so they fulfill octet row. So this bonding happen when they share their electrons, and that's a covalent bonding. So you can write electrons are shared equally by nuclei and that's where covalent bond happens. Now remember, ionic compounds, most of the ionic compounds, they possess positive and negative charge, right? So when you dissolve in water, it gives what? Ionic solutions. They conduct electricity. They produce electrolytes, right? While in here, electrons are shared equally, so there is no charge between them, no positive or negative charge between them, right? So even if you dissolve, they will not give ions. In their solution. Okay. Now let's talk about strength. Okay. Whenever positive and negative charges, they come close to each other, attract, they strongly bonded to each other. While in here, covalent bond, they share. So which bond is stronger? Remember, in this molecule, you want to separate them apart, Na and Cl, and Cl and Cl. Which one is taking more energy to separate them apart? NaCl, because they are strongly bonded. Positive and negative charge attraction between them. It's very difficult to break them apart. There is no space in between. You see that? In here, when due to the attraction, there is no space in between them. They are just stick to each other. In here, there is a space between them, right? When there is a more space, you can break them apart, right? So this one is usually in less strength or stronger, and the ionic bond is more stronger. So this one is more stronger. So now we are going to talk about polar covalent bond and non-polar covalent bond. So let's go to next slide. We learned ionic bonding and covalent bonding. Now we are going to talk about polar covalent bond and non-polar covalent bond. So, now in a covalent bonding there are two types of bondings, polar and non-polar. In polar covalent, when we said unequal sharing, of electrons between atoms, in a molecule, and in here you can say equal sharing of electrons between atoms a little structure and show it to you how they are differ. How can you tell one is polar and one is non-polar? So let's say, for example, we have HCl molecule, and we place 1 dot for hydrogen and 7 for chlorine, and they are sharing their electrons. In here, chlorine and chlorine, and they are sharing 1 electrons between them. So their bonding is right here. Now when you look at it, the sharing, this side, chlorine is more electron dense, right? So they are pulling this bond towards itself. It's unequal sharing of electrons. You see, this is more electron dense side. So polarity goes from hydrogen to chlorine. Now in here, polarity goes from chlorine and 1 chlorine. So they are equal sharing of electrons between atoms. This chlorine has 6 on one end, this chlorine has 6 on one end. So that's where you can say polarity both between those cancels out and make the molecule non-polar, right? So equal sharing and unequal sharing. This is, you can call, unequal sharing of electrons. You see one side there is more electrons in the bond, one side more electrons, on the bond here both sides equal electrons, right? So now when you place these molecules in an electric field, when you place these electrons in an electric field, what happens? Let's say this is electric field. When you place that, let's say this is positive charge and this is negative. So this end goes and attracts here because it's more electrons on this side, more negative charge on that side. And this one is going to be go towards positive side. So that way you can see electron field, effect of electron field on it. Okay. So ionic covalent bond, polar and non-polar covalent bond. Now we are going to talk about